airplane in the world, that's all.
Yes, it is the largest airplane in the world. The United States Air Force C-5 Galaxy. More than 80 yards long. Almost that great a wingspan. As high as a 6-story building. Able to carry a payload of more than 130 tons at a speed of 500 miles per hour. A beautiful, useful giant. The C-5 is big, all right, but it's part of something much bigger. It is a military air transport system, a fleet of giant transports backed up by the trained people and ground support equipment necessary to carry out this nation's peacekeeping and combat airlift responsibilities around the world. It's an aircraft of staggering statistics. And not the least of these is the fact that it rose from the drawing board to actual flight in less than 3 years. How did we do it? Why did we do it? Let's look in on an operational briefing. Military Airlift Command, Scott Air Force Base, Illinois.
There are 94 C-141s operating in the Pacific this morning, and of those 94, 32 are presently en route to Southeast Asian destinations and 28 returning from Southeast Asian destinations. The eastbound embassy mission is en route from Bangkok to Saigon and is operating on schedule. 3 distinguished visitors.
These are the men responsible for the nation's airlift missions. That's General Howell Estes, the commander in the center.
Now, I think you can see from this briefing that the tonnages that we have to move in resupply operations and troop deployments are very large, that we've got to move them to a lot of different places, and that we've got to get them there very rapidly. The C-5, when it enters our inventory, will permit us to do the job that we're doing today far more efficiently and far more effectively.
More efficiently, more effectively. During the Lebanon crisis of 1958, it required 200 aircraft to fly 3,000 tons of equipment. If the Galaxy had been available, fewer than 30 flights would have been required to do the job. During the India-China dispute of 1962, we moved 950 tons of ammunition from Germany to India. It required 46 C-135 flights. 10 C-5s would have done the job. In the Berlin airlift of 1948, the United States flew in 5,500 tons of cargo per day. It took 142 C-54s. Just 5 C-5s would have handled it. Blue Light was a massive airlift into Southeast Asia from Hickam Air Force Base, Hawaii, in 1965, utilizing C-141s, 133s, and 124s. It required 231 flights. With the C-5, it would have required only 65 flights. An operational C-5 fleet will revolutionize military airlift.
With the C-5 and the MAC force, we'll be capable of moving an entire Army division with its supporting elements and all of its outsized equipment, something like 40,000 people and 50,000 tons, intercontinentally, any place in the world, with great rapidity. Looking at the airlift task another way, this also means that you could move all of the ground personnel and equipment of an Air Force wing in an even shorter period, any place in the world. So what this means is that the C-5 gives us the kind of flexible response that we require to meet today's national military policy.
As General Estes pointed out, The why of the C-5 is rooted in our current military strategy. We need the ability to respond all out, but we also need military readiness for small and scattered actions anywhere. This called for a plane that would deliver men and their fighting equipment into a combat area ready to fight. Tankers with their tanks, bridge builders with their bridge. This called for a gigantic step ahead in United States aircraft design philosophy. In the past, we had often asked, what can we build with what we have? This time we ask, what must we haul? How far? How fast? At what cost? Design engineers soon had their staggering answer. What we needed was a short, 3-lane street that would fly with a ramp at either end.
Cargo or trucks can then be loaded directly over the ramp extension and the forward ramp up into the cargo hold, all the way through the 121 feet of cargo floor space, and could exit back out over the aft ramp and the aft pressure door.
What kind of a wing does it take to lift a 3-lane street? And how do you set it down on a crude landing strip with a surface strength roughly equivalent to the outfield at Yankee Stadium? Can a 380-ton plane have a light footprint? American ingenuity said, sure it can, and produced a 28-wheel gear with tires that can be deflated in flight for softer landings on bare soil. It allows the plane to kneel, lowering the cargo floor almost 3 feet for easier cargo handling. And it tilts to conform the ramp to uneven ground. Then, after fast unloading, the giant C-5 can turn on a narrow strip without the help of tugs and get on its way again. Other engineers had to invent an engine that could thrust a 3-lane street across the sky at more than 500 miles an hour and carry cargo at the lowest ton-mile cost in history. Double the power of our biggest modern fan jets, but don't double the weight. And there were shipping problems to solve, too.
Well, now, Frank, you know this center wing section has to have a specially built car from the rails up.
Right.
And it's going to take about 12 months to produce that car and have it ready for shipment. I believe we can do it 12. You think we'd do it 10, Bill, if we had to?
From nose to tail, there were new design problems to solve. Proposed designs came back to the Air Force, spelled out in about 60,000 pages apiece. One was selected. It outlined the world's most fantastic airplane. Then, all across the nation, people went to work to bring this giant aircraft into being. Managing the program is the task of the C-5 System Program Office, or SPO, of the Air Force Systems Command at Wright-Patterson Air Force Base, Ohio. This is the nerve center, where the Air Force monitors the where and how of building the aircraft and meeting an unprecedented schedule. The Lockheed Georgia Company, prime contractor for the aircraft, set up a special task force under Jack Mann to coordinate the efforts of the many subcontractors.
Our subcontractors are doing a tremendous job. Each major subcontractor has appointed a program manager for the C-5 project. Initially, a few red flags did go up as a result of high program demands, Take coordination alone. The Northrop people in Hawthorne, California, making the inertial navigation system, must mesh with Norden Division of United Aircraft, making the multimode radar in Connecticut, and Minneapolis Honeywell, making the automatic flight control system. The empennage is built by Convair, and the landing gear by both Bendix and Monasco. Bendix makes the main struts, Monasco the six-wheel bogies. So American companies are developing a tremendous ability to coordinate on the C-5. And to tell you the truth, they're telling us it's a great practice internally, too.
21 major subcontractors are involved in the effort. Engine nacelles come from Rohr Corporation at Chula Vista, California. Brunswick Corporation at Marion, Virginia supplies the nose ray domes. Major wing sections are built in Nashville, Tennessee by Avco. The size of the wing and the complexity of machining present a challenge. The wing skin is fabricated from thick aluminum extrusions, deeply milled to leave a thin skin with deep projections for strength and rigidity, and to ensure perfect joints. Machining beds had to be lengthened 25 feet, and their electronic controls modified. This $1 million mill takes a 3,000-pound extrusion and carves it down to 600 pounds of precision wing sections. Also unique in making this wing is the shot peening process. Millions of small pellets are fired at the wing plank. The pellets dent the surface, which relieves surface tension and prevents cracks from forming. The wing will flex to an extreme degree in flight. Thus, sealing becomes difficult, and especially when you consider that there are 400,000 fasteners to seal. The fasteners are larger than the holes and are forced through, making a tight, firm fit. The seal must be perfect, for the wing is also the fuel tank. Precision assembly is crucial because many other subcontractors are making components which must fit to it, on it, and into it. If each workman and each contractor work to the outside limit of the dimensional tolerance, the tolerance buildup at Marietta would, well, be too snug. Therefore, everyone is reaching for the center of the tolerance. And finally, the wing is on its way to completion. It will be protected in transit by a slipcover made by the Nashville Tent and Awning Company in Nashville, Tennessee, one of the many small suppliers who are surprised and pleased to find themselves in the aircraft business. The Avco outer wing sections must mate exactly with wing tips, leading edges, and ailerons manufactured by Canadair Limited in Montreal.
We're doing nicely, but I must admit it's only due to the extreme project cooperation. You see, we started out with a high lift system. Then, rather late in the game, but as a result of continuing wind tunnel testing, Lockheed engineers found they were becoming critical on the three-engine climb-out. They wanted to trade off some lift capability for some freedom from drag to improve that climb rate. So they shifted to a Fowler flap system, which also changed the slat design. To accommodate a design change this important, this late, and still meet schedule, puts the heat on. And it takes good cooperation all round, as well as good management by primes and subs.
General Electric drew the unprecedented engine assignment. Enough power to lift about 50 tons of cargo over a distance of 5,000 miles at more than 500 miles per hour. The engine, which must be capable of operating in any type of climate, passed its ground tests, then was mounted to the wing of a B-52 for air tests at the Air Force Flight Test Center, although no existing aircraft could truly simulate a C-5. the new power plant functions beautifully, beginning a program that may require almost 1,000 of these engines. Keeping a close watch on the weight of all C-5 components is Lockheed's Whit Holland.
And as we discover certain components that we can redesign lighter via more expensive material or otherwise, we store these in this bank. Then we know exactly where to go when we need to cut some weight. Our move to titanium is one example.
The weight problem is compounded by the need for brute strength. An example is this giant rib being forged on the free world's largest press at Alcoa, Cleveland. It will join the wing to the fuselage. Flying the C-5 would be very difficult with a standard control system because of the plane's tremendous size. So, rather than train pilots to fly a new way, engineers modified the control system electronically so that traditional pilot movements are translated into the desired aircraft reaction.
And here at Hobson Limited in England, we're designing a system that applies hydraulic back pressure to the flight controls. This is so your pilot can get the feel that he's flying an aircraft and not a warehouse.
Onboard avionics are the most advanced systems for sensing, computational ability, and guidance. For example, an energy management computer helps the navigator plan the best route for fuel economy. An exceptional radar system helps the C-5 avoid terrain hazards during low-altitude operation at night or in bad weather. Here is perhaps the most revolutionary of the Galaxy's subsystems, MADAR, Malfunction Detection Analysis and Recording System, an on-board electronics troubleshooter. Like a giant cardiograph, MADAR performs an instant physical exam on 650 points of the aircraft subsystems every 30 seconds, and a computerized analyzer reports to the flight engineer. If MADAR detects a malfunction, it tells the operator how to fix it and the federal stock number of any parts which need replacement. This number can be transmitted to the next landing site, and the part will be waiting when the C-5 lands. As fabrication of the C-5's parts moves ahead, so does provision for all of the many support systems necessary to keep it in the air. Lockheed developed this simulator, which will be used to familiarize Air Force pilots and flight crews with the C-5 systems. The Air Force controls logistics support and maintenance training. Air Force Logistics Command supplies all C-5 replacement parts and performs major overhauls at San Antonio Air Materiel Area. Air Training Command is responsible for instructing several thousand maintenance personnel in the servicing and repair of the C-5. Contractors began turning out ground support equipment, including giant engine test stands, 130,000 spare parts, managed and inventoried at the right places around the world. Enormous repair stands, hundreds of special tools, tow bars, and fuel trucks. It takes 10 of these 5,000-gallon trucks to fill the tanks of the C-5. As the massive project moves forward in the subcontractors' plants, a special computer system at Lockheed digests hourly inputs from all across the nation. Any test that fails, any scheduled drift, any design shift, any shortage. Project managers are advised of trouble immediately and can take action before it grows. And production hits a peak of activity. Finished components flow in an increasing stream from the plants of suppliers to Lockheed, where the giant aircraft gradually take shape. The day finally comes when construction is completed and the largest aircraft ever built is rolled out onto the ramp and introduced to the world. Then, on the last day of June, 1968, less than 3 years after the fantastic project began, the C-5 Galaxy taxied out for its maiden flight.
Everybody happy? Everybody happy. Brake suspension going on. Okay. My records are running. Okay. Okay. Watch her up. The flight recorder is on. Steady. Ready to go. Rolling. Hello? Let's go then. I got 65, 70, 75, 80, 90, 100, Roger, 110, 120, going out. Airborne. Airborne is good. Oh, good. Go to limiter. Looks beautiful. Everything's fine. Tail ground looking good. You look good from down here too. I just feels real solid. No staff either. Okay, we're fine trimmed at 140 knots, hands off, real smooth. Oh, the Lake Lanier, the Beaufort Dam at the present time, 8,500 feet. Okay, flight 303s through 9,000, approaching 10. If you listen to 120.35, you'll find our theme song. At 202, your message came through loud and clear.
A new bird is in the air, ready to move cargo and combat forces anywhere on Earth, more efficiently and more effectively than ever before. And as this first of the C-5 galaxies casts its shadow across the Earth, the thousands of men and women who built it turn back to the task of producing the C-5 squadrons that are to come. It's a beautiful day for the free world.